ቪዲዮ የ11ኛ ክፍል ዩኒት 1 ኤክሰርሳይዝ 1.5 ኤክሰርሳይዙን እና ሶሉሽኑን ይዤ የቀረብኩላችሁ። ወደ ጥያቄውና ሶሉሽኑ ከመግባታችን በፊት ኤክሰርሳይዝ 1.5 በዚህ ጥያቄ ላይ የተጠየቅናቸው ጥያቄ አስቀድመን find the inverse domain and range of the following relations. The relations are given: relation A, B, and C. Let's start the solution from A. Solution from A. Solution. A relation R is given. A relation R is given as follows, with the order pairs 1, 3, 2, 4, and 3, 9. To find the inverse, simply the inverse is of such type of relation is exchanging the first components of each order pairs. Thus, we have the following relation. The inverse is R inverse is equal to, here the relation is 1, 3, then the inverse is 3, 1, and here 2, 4, but the inverse is 4, 2, and the inverse of 3, 9 is 9, 3. The second thing we are asked to find is the domain and range of the relation and its inverse. From the given relation, the domain of R, all the first components of the order pairs. This implies the domain is the set containing 1, the first components of each term, 1, 2, and 3. And the range of R, the range of the relation R is the second component of each order pair. These are 3, 4, and 9. The range is a set containing 3, 4, and 9. After this, it is simple to determine the domain and range of R inverse, because remark, the domain of R is equivalent with range of R inverse. Similarly, range of R is equivalent with domain of R. Hence, in our problem, the domain of R and the range of the domain and R and the range of R are already determined. Therefore, the domain of the inverse is R inverse is the range of R, which is a set containing 3, 4, and 9. The second one, the range of R inverse is the domain of R. The domain of R. Thus, it is a set containing 1, 2, 3. This is the solution for the first problem. With the second question, B, given a relation S, the relation is S, defined as x, y, such that x and y are elements of real number with relation such that x, y is element of real number and y is equals to 2x minus 4. This equation is very important, which determines the properties of x and y in this relation. Therefore, to find the inverse, first we are asked to find the inverse. To find the inverse, the first step is step 1, we have to exchange x and y in y is equals to 2x minus 4. Therefore, we get, in place of y we write x, in place of x we write y. This implies x is equals to 2y minus 4. After this, the second step is step 2, solve for y. After we exchanged x and y, the second step is to solve for y. Consider x is equals to 2y minus 4. Consider x is equals to 2y minus 4. To write this in terms of y, first let us add 4 to both sides. This implies x plus 4 is equal with 2y. Adding 4 to both sides. After this, dividing both sides by 2, we will get y is equals to x plus 4 over 2. Therefore, S inverse, the inverse of this relation, S inverse is equal with or given as x comma y, such that x and y are elements of real number and y and x are related with the equation y is equals to x plus 4 over 2. This is the inverse for S. Next, we have to find the domain and range of S and S inverse. The relation S is characterized by y is equals to 2x minus 4, which is obvious. We know that it is a linear equation, and here x and y are taken from real number. Domain of S is the set of all real number, and again range of S is the set of real number. In contrast, the domain of S inverse is the range of S, which is again real number, and the range of S inverse is the domain of S, which is real number. Next, we will see the solution for question for the relation which is given on the C. The given relation is relation T, which is defined as x comma y, such that x and y are elements of real number, where the relation of x and y are given by these two inequalities, y greater or equals to 2x plus 1 and y less or equals to x minus 2. First thing we are going to find is the inverse of the relation. That is, we are going to find T inverse. Then we have to find the domain and range of T inverse. First, let us find the inverse of the relation T. To find the inverse of T, we consider the inequalities y is greater or equals to 2x plus 1 and y less or equals to x minus 2. As you remember, the first step is to interchange. Step 1, interchange x and y. That is, interchanging x and y, we will obtain the following inequalities. X is greater or equals to 2y plus 1, and from the second inequality, x is less or equals to y minus 2. Then after, second step, solve for y. That is, write the inequality in terms of y. Then it follows Here we obtained x greater or equals to 2y plus 1. First, let us rewrite this inequality in terms of y. Then, collecting like terms, we'll get the following result: x minus 1 greater or equals to 2y. From the right side, we divide both sides by 2, and we obtain x minus 1 over 2 greater or equals to y. This in turn is the same as y is less or equals to x minus 1 over 2. This is the inverse of the inequality y is greater or equals to 2x plus 1. Next, consider the second inequality, which is x less or equals to y minus 2. Rewriting this inequality in terms of y, we will obtain the following result: x plus 2 less or equals to y, by adding 2 to both sides. This is the same as y is greater or equals to x plus 2. Now, we obtained the inverse of the relations x is less or equals to minus 2 and y is less or equals to minus 1 over 2. Therefore, for the given relation T inverse is equal with x comma y, such that x and y are elements of real number, and the inequalities are newly determined inequalities: x minus 1 over 2 and y greater or equals to x plus 2. This is the inverse for the given relation T. Well, the second thing we are going to determine is the domain and range of T inverse. To determine the domain and range of the given inverse function, we can recall the property of domain and range of a relation, and it is the inverse, which is related in the form: the domain of T is the same as range of T inverse, and range of T is again equal with domain of T inverse. Therefore, to obtain a range and domain of T inverse, it is enough to determine the domain range of the given relation T. Now to determine domain and range of T, let us sketch the graph of the relation T. To sketch the graph of the relation T, we consider the two inequalities: y greater or equals to 2x plus 1 and y is less or equals to x minus 2. To sketch such a graph, first we have to consider the equality version of the inequalities. That is first we have to sketch the graph of the equality. Let's consider y is equals to 2x plus 1 from this inequality, and take y is equals to x minus 2 from the second inequality. As you can see, the equations are linear functions. Therefore, to sketch the graph of linear function, it is important to recall about the x-intercept and y-intercept of linear functions. Let us first sketch the graph of y is equals to 2x plus 1. For any linear equation, y is equals to mx plus b, x-intercept is minus b over m comma 0, and y-intercept is 0, b. Remember, it is written in the standard form. And if m is positive, then the graph is increasing. And if m is negative, the graph is decreasing. Recalling this property, we can determine x-intercept, y-intercept, and the monotonicity of this linear function as follows. Thus, x-intercept is minus b over m, 0, where b is 1, m is 2. Therefore, this is minus 1 over 2, 0. Y-intercept is 0, b, but the value of b is 1. Thus, the graph touches y-axis at 0, 1. The value of b is 1. And from the sign of m is equals to 2, which is positive. This implies the graph is increasing. Therefore, putting these basic things on our Cartesian coordinates, we'll have the following graph for y. Y is equals to x plus 1. The first thing is the x-intercept. The graph touches x-axis at negative 1 over 2, 0, and y-axis at 0, 1. Negative 1 over 2, 0, and this is 0, 1. And the graph is increasing, therefore it will have the following form. This is the graph of y is equals to 2x plus 1. But our relation is the inequality form y greater or equals to 2x plus 1. This is to mean we have to shade above the line y is equals to 2x plus 1 as follows. Now we already obtained the region where y is greater or equals to 2x plus 1. This the blue shaded region indicates the region where y is greater or equals to 2x plus 1. The second thing is we have to draw the second inequality, that is y is less or equals to x minus 2. To do this, we consider the line y is equals to x minus 2. Y is equals to x minus 2. Similar to the above linear function, where x-intercept is minus b over m, 0, but b is 1, but b is minus 2 and m is 1. Thus, this equal with negative of negative 2 over 1, 0, which is equal with positive 2, 0. Second, y-intercept is 0, b. The value of b is negative 2. Then we have 0, minus 2. These are the points where the graph touches x-axis and y-axis. The other important thing is the monotonicity. Since m is equals to 1, which is positive, this implies the graph is increasing. Now, putting all these important concepts on our coordinate axis, we will obtain the following result. The first thing is to put x-intercept, that is the graph touches x-axis at 2 and the y-axis at negative 2. And it is increasing graph. We will have the following form. Then the graph of y is equals to x minus 2, we have the following form, but our target is to determine the region where y is less or equals to x minus 2. That is below the graph of y is equals to x minus 2. Let us shade this by red color. As we can see, the region where the blue and red colors merge is this area. This shaded region indicates the relation T with the inequalities y is greater or equals to 2x plus 1 and y less or equals to x minus 2. To determine the domain and range, we have to find the intersection point. To find the intersection of the lines y is equals to 2x plus 1 and y is equals to x minus 2, we consider the equation 2x plus 1 is equals to x minus 2. After this collecting like term, we have the following relation: 2x minus x is equal with minus 2 minus 1 on the right side, and as the last we will get x is equals to negative 3. This is the point where the lines intersect at negative 3. And substituting back x minus 3 into one of these equations, let us consider the first one, y is equals to x plus 1. Then we will get the following result. Substituting negative 3 in this linear equation, we will get 2 times negative 3 plus 1, which is equal with negative 6 plus 1, and the value of y is negative 5. Again, this is where the two graphs intersect each other. That is the point negative 3, comma negative 5. After this, we can determine the domain and range easily by looking the region where the relation is shaded. As you can see, the region is shaded below negative 3 and below negative 5. Therefore, the domain is the value of the x coordinate and range is the value of y coordinate. Therefore, the domain of the relation T is x such that x is less or equals to negative 3, and the range of T is x, and the range of relation T is y such that y is less or equals to minus 5. Then after, by taking the relation of the property of domain and range of relation and its inverse, you can easily determine the domain of T inverse and range of T inverse as follows. Domain of T inverse is the same as range of T, which is but x such that x is less or equals to minus 5. Only we interchange x, the variables, and the range of T inverse is the same as domain of T, which is we replace x by y, then we have y such that y is less or equals to minus 3.